Hello, this is Zephyr from Innovators3311, and today I'm going to teach you a little bit about Fusion 360 CAM.
Okay, so here in Fusion 360, I have this relatively simple part I've modeled up, and I want to make it on a CNC machine. So to do that, I will first go to Manufacture and add a setup. This setup is basically what contains what kind of machine you're using, the stock information, your work coordinate system, and what you're actually making, which is this model. So for the work coordinate system, this is pretty important because this orients every operation in the same way that your CNC machine will see it. So for most CNC machines, Z is up, and Y and X can change between machines, but it doesn't usually. And so just keep those the same, and you can mess around if you feel like something's wrong. And here in stock, you can set stock offsets, and or you can change like whether it's a cylinder, just a relative box, or a fixed size. I like to use relative size for simple parts like this, and change the top offset to 0. And for the purposes of this video, I will turn stock offset, the sides offset, to just a little higher so we can see what's going on a little better, but I like to also keep that at 0. So now that we have our setup, we need to add an operation. And I think the best place to start is with these holes. To make these holes, one option would be to just add a contour here, which would, well, here, let me grab my tool real quick. I'm using an 1/8 inch end mill for this video. As you can see, it leaves this chunk of material in the middle here, which is not ideal because that can be released, that'll be loose in there, so it could get caught between your cutter and the wall of your part and either break the cutter or send your part flying across the room, which neither of those things you want. So an easy way to get around that, and a pretty effective way too, would be to use an adaptive clear, a 2D adaptive, and select that again, and what that'll do is that'll start from the middle and open up the part rather than just cutting out the shape you want. So that's that. And a little bit more on that is optimal load is what is how wide the cutter will always be cutting. It will never exceed the optimal load, which is very useful for hobby machines where you're wanting to push the limits of your machine, but if you go too far above that, you're either going to break your tool or something else, which would not end up very well. So this optimal load keeps things very consistent and predictable. So for hobby machines, I found that 0.5 millimeter optimal load is pretty good for an 1/8 inch tool. And stock to leave is what it sounds like. It's dictating how much stock is being left. With a 0.5 radial stock to leave, that'll add 0.5 millimeters this way on the edge, so it'll make a smaller circle than what it should. So for this, I'll turn that off. Stock to leave is useful for finishing passes to pretty up the surface finish or get a more tight tolerance, but I won't go into that for now. And here in linking, there's the ramp option, which is just extremely useful because it avoids plunging your end mill into the work, and it is pretty controllable. So what I like to do is I set it to 1 degree instead of 2 degrees because it's a little it's a little shallower. It'll take a little longer, but it's a lot easier on your tool. And on top of that, we have feed rate. I like to have the feed rate around, cutting feed rate around 400 millimeters per second, or millimeters per minute. So I'll just type in 400 millimeters. So, and then for ramp feed rate, I like to have a little bit lower, just because it has more cutter engagement. But 300 for that, 400 for that. You can, whatever machine you're on, you're gonna have to experiment with that just to see what works best on your machine. So, well, I found a pretty good number is 400. So there's that, our first operation. And just to finish that off, we'll go back in again and select the rest of our holes. And that finishes them all off. Next up, we have these little holes, which are a little tough to do with an adaptive. It's not impossible, but it's a little impractical because once you're down in there, it's such a small hole. It's so close to the diameter of the tool that all the chips you're making will just get packed in there and break your tool. So I found it's better to do a boring operation. It'll do very small diameter holes without plunging the end mill by making a small helix downwards, and that's a little too steep for an 1/8 inch end mill, I think, so I'll set that to 0.2 instead, which looks pretty good to me. That'll send your tool spiraling down in there instead of plunging it. And then finally, we have to cut out the actual part, the outline. So the most commonly used toolpath for that would be a contour, which is what I showed over here, but on the outside of the tool, on the outside of the part. So what that'll do is just cut around the outside. This, though, is not ideal. First of all, it plunged straight into the part, or straight into the stock, which is not good. It'll probably break your end mill. Well, definitely will. And it's got full engagement on the cutter, and it's at a full depth of cut, which will also definitely break your tool. So to get around that, we'll add a few more passes. No, not roughing passes, multiple depths. And I'll set that to 0.2 millimeters. That'll leave very small step downs. That'll be easier on the cutter and your machine. And to avoid plunging, we'll turn on ramp again and turn this angle down again. So now we have a lot more passes and our tool ramps into the part. That's what this red line means. It's ramping into the part. This, though, there's another way to do this, which is a little bit more optimal, because right now, if I go to machining time, that's a 25-minute operation, which is not ideal. So for now, I'll suppress this. That'll just clear the tool path and keep it from generating again. And I found a neat trick is to go into design again, and create a new sketch at the bottom of your part or around whatever contour your machine. And then use a offset and offset it a bit more than the width of your tool, but for this example I'll just do 0.25 and finish that. So now we have an extra outline around the part that we can go into manufacture again. Now that I changed the part, I have to redo this, so I'll just generate these again. And now we'll use adaptive clearing again to rough around the outside of this part. And we're going to use the same optimal load as before, 0.5. Same speeds, they're all saved in here. Same cutter. And that doesn't look right. That's cutting the inside of the part. So how to fix that is to go back into edit again. And over here in geometry, flip the direction of these arrows. So now that does this portion instead of the inside and the outside. Wait for that to generate. Okay, so we got an error, which is normal for this because we don't have enough space for our ramping operate. We don't have enough space for our tool to ramp into the part because our diameter is set larger than this area I've allocated for this operation. So for this, to solve this, I'll just change this to say 1 millimeter. Let's see if that works a little better. Yep, now it's able to ramp down into the part, and as you can see, it's taking, instead of going one outline around the part, it's taking smaller bites from the stock at once to just keep that optimal load and just be a little easier on your cutter. Also, it's faster. It will take a long time to generate depending on what computer you have, but I'll just let this generate. Okay, now back with this, now that it's generated, we can see if I go into simulation, it spirals down into the part like normal, and it just takes small bites away from the part. This is a lot better on your tool and your machine. You don't need as much rigidity or power. You don't need as much horsepower in your spindle. And it's shorter too. If I go over here and hit machining time, well, maybe I was wrong. Let me see. Well, I guess it's maybe not shorter in this case, but I know it's been shorter in some cases that I've had to use this, but it's an alternative to contours if you're having trouble with that. So I think that's about it for the cam side of things. Oh wait, you'll need to post-process this so that it'll convert all of these into G-code that your machine can use. So my machine runs off of Gerbil, so I post with the Gerbil post processor. And you can type in your program name and just post it. And that'll save as whatever you've typed in here or whatever you want to save it as. You can change the name later. But I think that's about it for cam.